Hi everybody, welcome to the Manifold channel. I'm going to get an import started while we're talking so I can not take too much time. We're going to import this 1 gigabyte TIFF file. I'm going to click File, Import, and then click TIFF. And Manifold's going to go ahead and import it. And it knows that it's a TIFF because it's looking at the extension TIFF, and it's also looking inside the file to know what kind of TIFF it is. And there it's done. That's about how long it takes to import a 1 gigabyte TIFF in Manifold or Manifold Viewer. We're looking at the free Manifold Viewer here. I'm going to double click this to take a look at what it is. And what we see here is that's a terrain elevation file that was created by the Space Shuttle Radar Topography Mission, if I've got that acronym correct. And we're going to style this. I'm going to click Contents, Style, and let's use one channel because it's just one channel elevation data, and we'll style that using the Color Brewer Accent Palette. Now let's use the Color Brewer. Let's use this palette down here. Oh, what the heck, let's use that palette there. Kind of ugly, but let's reverse that. Looks a little bit better. And let's use shading with Z-scale of 0.2. Click Update. And now we've hill shaded that. We're going to be working with the Richat Structure here in Africa. It's called the Eye of Africa. As you can see, it kind of looks like an eye. And what we're working with here is we're working with Manifold Viewer, which is a free software. Viewer is the read-only free version of Manifold System Release 9. It's fully CPU parallel like Release 9, and it's fully GPU parallel like Release 9. So it's an absolutely fantastic software. It cannot save a project, but it can read from a near infinity of sources, and we can do cool tricks. Like, for example, if I want to change the style of this, I can save styles and things like Notepad. So I can copy this right here. Styles in Manifold are just simply JSON strings. I can click Copy, and then I can go here to the, whoops, right there. Right click on that, choose Properties, click Paste, click Update, and I've just updated the Style Pixel property using that style, which gives me some better discrimination, better differences in terms of the terrain elevation data heights. We can do even trickier things. For example, you can write full SQL queries in Release in Viewer, and even though we can't save those queries, we can copy from the command window and we can paste them to things like Notepad. So here's that Notepad document again. Here's a query that I saved earlier. I can copy that and paste it here. Now I'll click the Run button to run it. And what this query is going to do is going to change the integer data that's in the Space Shuttle terrain elevation data. In that TIFF, there's a bunch of 16-bit integers, and we want to. It's done already, and we want to change them to floating point numbers. It took it that long to go through all the 1 gigabyte and change all those, recompute all the tiles as float 64s instead of 16-bit integers. The display still looks the same because Manifold doesn't care what it's displaying here. You know, once we style it, it'll use the numbers for style. But why do we change these numbers? We change the numbers to floating point because we're going to do some calculations here where we don't want to be rounded down because it's integer calculations. We want to do curvature computations. Now, to play with this a little bit more, let's add a map. Let's create a map. And the map will be in default pseudo Mercator. I'll open the map, and let's create a web source. And I'm going to use Bing Satellite, Map Satellite for my web source favorites. Drag and drop Bing Satellite into there. And if we look at the contents pane here, the component, we see that this is all in pseudo Mercator. If I click back here on the SRTM, we see that's in latitude and longitude, which is what EPSG 4326 is. And what's really cool about Manifold and Viewer is that with unbelievable speed, we can take this SRTM and drag it and drop it into there, and Manifold instantly reprojects it on the fly. So even though it's reprojecting that 1 gigabyte SRTM into the pseudo Mercator data set that's used by Bing, you can see it's perfectly georegistered. It's georegistered right on top of that data set that Bing uses, and it's being done effectively instantly. Let's play with Bing a bit because as you can see in this data set that we linked in, that there's a little lock there that shows that it's a read-only data set. Why is it a read-only data set? Because Microsoft allows you to read from their servers, which is where all this is coming from, but we can't write up into those servers. So everything up on this side of part of the project, that's within Microsoft's data set, Microsoft's data source, and that's all read-only. What we can do is we can copy that satellite image and we can paste it down here. And what we've done is we've basically pasted a link. If I right-click on the properties in this, we can see that the satellite image is taking its data from this table, which is the Bing Maps satellite table. So it's inside the data source. And it's creating that on the fly. If we drag and drop that image into the map, we see it's identically the same image, because both this image here and that image there are both getting their data from this table right there. The difference is that this image is inside our project where we can mess with it. I'm going to turn that off and delete from that. And now we're just left with here. But because this is in the map, we can now change the style properties for this image. So we can do things like click on Style. And if I want to do goofy stuff like change the channel assignments, I can change them instantly to use different channel numbers. I can turn individual channels on and off. Let's go back here to the default. I can do things like recompute what the stretch is for all these intervals. For example, I can do an auto contrast set to high and recompute the numbers to auto contrast. Click Update Style, and it shows me a higher contrast view of the same thing. If I compare that to what the original was, and I can use them both at the same time here, you can see the original here is a little bit duller, and the auto contrast one is a little bit brighter, and it's more contrasty in some spots. We're going to use that because that's going to do a better job of shining through upper layers. I'm going to turn this, going to delete that from the map. Let's turn that SRTM layer back on, and what I will do is I will change the transparency of this SRTM layer using the layers pane to 50%. So that's going to allow some of the Bing satellite map to shine right through. So here right away is a first example of using Viewer to create a blended image where we are blending the SRTM data with the Manifold Bing Map satellite image. And it's not just the Bing Map satellite image, it's the Bing Map satellite image as we have enhanced it on the fly. We're doing that all automatically on the fly. Let's do something cool here. Let's calculate the profile curvature. Now, guys who know what profile curvature is are right away thinking, hey, wait a minute, man, I don't want to spend the next 2 days waiting for this to cook. But we're not going to have to spend the next couple days, because if we look in here to help about, we can see that what we have here is a pretty lame CPU. That's an $85 CPU. It's an ancient AMD FX 8300 8-core processor. You can buy those on Newegg now for about $85. But it has two CUDA devices, and one of those CUDA devices is a $250 GTX 1060 Ti, which has 1,280 CUDA cores. Now, gamers won't think of that as any sort of a big-time GPU card, but for those of us who are doing computations on Viewer, and we can use all those 1,280 cores in parallel, that can do some really, really fast work for us. So let's compute the profile, and we'll compute it with the radius of 2, which is a 7x7 matrix. I'm going to start that computation going. It's going to take us 42 seconds, and while it's taking 42 seconds to do that, let's pop up in a website here to see what it's calculating. What we're calculating is curvature, and we're using this wonderful blog article that's an ArcGIS blog by Aileen Buckley. And I guess it's kind of cheeky of us to use ArcGIS blogs, but you know, Esri does a wonderful job educating people on what GIS is. And what profile curvature does is it computes what the curvature is at any spot of a surface. And if the surface is just a flat inclined plane, there's zero curvature. If it's curved this way, it's positive curvature. If it's curved that way, it's minus curvature. And by computing what curvature is, you can get displays like this showing the more curved. Oops, it's done already. And let's see what that created. We're going to drag and drop the curvature image into here. And let's style that, because that is a floating point image. And I'm going to auto contrast to medium. What we'll do is it's a floating point value from -1 to +1. I'm going to click Update Style, and you can see a classic sort of curvature presentation where it's picked out, profile picks out terraces, and it picks out crater rims. So any place where perpendicular to the slope there's a big change, for example, in the case of a ridge or a terrace, here's a terrace right there. here's a ridge. It'll emphasize that. And as you can see, Manifold computed all this, and it computed all of it in a perfectly georegistered way. Let us turn off that, and let's take the Bing Map satellite image, and we will, in the Layers pane, change that to 80% transparency so that some of the curvature can shine through from below. And now what you can see, what's happening is that the curvature layer is shining through from below, and it's accentuating the terrace here and accentuating the ridges. If we zoom in a little bit, we can see how the curvature there, it's going to take Bing a second or two, because notice that we're actually loading stuff in from the Bing server on the fly, and that those tiles that we're bringing in from the server on the fly are being enhanced for contrast. And where they combine, by showing with 80% opacity, showing some of the curvature layer through, we get kind of these heightened effects for terraces and ridges. And we can highlight that even more, and you can see it's a really big effect right up here, by turning on the SRTM output. To get the SRTM output and the combined effect even brighter than what you see here, what we can do is we can copy some other style, for example a brighter SRTM style, and use brighter colors here. But we're just going to leave this as this is, because the video is already running about 11 minutes, and we don't want to take too much of our viewers' time. So let's add a label, and the way we're going to add a label is create labels. Cool. Let's drag and drop the labels component into the map, and there it is. And let's create a point label. Let's create it right here. Got to click that, and here I'll put in Richat Structure. That's a French word. I'm sure the French are unhappy with how I'm pronouncing it, but that's the name of the guy that I believe found it. And it's going to create a label in the default styling there. Let's style that label, the styling pane, and I'll do a combined kind of style here to let's click the background here. Let's make that label white, and let's make it about I don't know, 18 points big. Let's click the shadow box to put a shadow here in black, a drop shadow, and we'll offset that at 135 degrees to about 2 points. So that should be cool. Great. We've just used a free product to create a reasonably cool display here. Something that would take you many hours, if not days, if you're using a non-parallel GIS, because to compute things like curvature in a non-parallel GIS, to do it in a 7x7 matrix, will take you hours, if not days. And as you can see, we did that in just 40 seconds here. We're also working with reasonably big data. We're working with this incredibly large Bing Map satellite image, and we have a gigabyte worth of output SRTM. And this curvature profile layer is also about a gigabyte, because we did the curvature profile for the entire SRTM tile, the entire 1 gigabyte. It went that quickly that we don't have to just cut out a little bit of piece of it to limit the amount of computations that we're doing. We could just do the whole thing at once, and if we're working with 2 gigabytes of data at a time, that's absolutely no big deal. That's absolutely effortless for Manifold Viewer. And we can dock and undock this by alt-clicking the title bar. So we can undock it and pan and zoom as we like, and then alt print screen, which is a Microsoft Windows word move that says do a screenshot of what's in that window, and then paste it into GIMP or Photoshop or even Microsoft Paint, and manipulate the image as we like. We can change the colors thereafter. We could adjust contrast if we don't want to adjust the contrast here, and clip it out and save it as a picture for a website or for a PDF or some report that we're doing or whatever. So you can use this free product, Manifold Viewer, to create spectacular images. You don't have to pay a dime. As you can see, it works so fast that even if you have to import everything to start it, you can do that. You can save frequently used styles and queries and other things in plain ordinary text documents. No problem with copying and pasting to and from Viewer to do that sort of thing. And it's a completely free product. If you want the convenience of storing all this as a Manifold project, well, you can do that too. For that, you'll need the commercial version. You have to buy that. But there's no obligation to do that with Viewer. You don't have to register with Viewer. So you don't have to give your email address. You'll never get spammed. There's no upsell in a viewer. There's no advertising. There's no begging for donations. None of that stuff. You just free software in the old-fashioned way where you can download it and use it for however you like for as long as you like. I hope you've enjoyed this video. Download Viewer and get cracking right now and creating cool images and other things. And thanks for watching. Goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.